Hello, everyone. We all know that unstable foundations, earth-shaking tremors. In addition to the plate load test we learned earlier, what other foundation-bearing capacity test methods exist? This section covers dynamic cone penetration test content. We focus on learning the following contents. First, dynamic cone penetration test. Second, test equipment. Third, key points of dynamic cone penetration test methods using the light type as an example. First, let us understand the definition of dynamic cone penetration test. Dynamic cone penetration test. Utilize a certain hammer impact energy. Drive a specified size cone probe into the soil. Then, based on the penetration blow count or dynamic penetration resistance, determine changes in the soil layer. Determine the engineering properties of soil. Conduct geotechnical engineering evaluation of foundation soil. The main purposes of dynamic penetration test indicators are as follows. First, evaluate the void ratio or relative density of sandy soil, and the state of silt and cohesive soil. Second, estimate soil strength and deformation modulus. Third, evaluate the uniformity and bearing capacity of site foundations. Fourth, detect soil cavities, slip surfaces, interfaces between hard or soft soil layers, etc. Fifth, estimate the bearing stratum and bearing capacity of pile foundations. Sixth, inspect the quality and effectiveness of foundation reinforcement and improvement. Understood the purpose of dynamic cone penetration test. Next, let us learn about the types and scope of application of dynamic cone penetration tests. First, types of dynamic cone penetration tests. Types of dynamic cone penetration test are divided into light type, heavy type, and super heavy type. Types and specifications of various tests are shown in the table. Second, application scope of dynamic cone penetration test. Light type dynamic cone penetration test. Generally used for cohesive soil with penetration depth less than 4 meters, plain fill, and silt composed of cohesive soil. Can be used for construction trench inspection, foundation examination, and detection of ground improvement effects. Heavy type dynamic cone penetration test. Generally applicable to sandy soil, such as gravelly soil below medium density and extremely soft rock. Super heavy type dynamic cone penetration test. Generally applicable to relatively dense gravelly soil, extremely soft rock, and soft rock, such as gravelly soil below medium density and extremely soft rock. The basic principle of DPT can be analyzed using the energy balance method. Energy conversion during single hammer impact follows energy conservation principle. The relationship is M equals EC plus EF plus EP plus EE. Next, let's examine equipment used in dynamic cone penetration test. Include guide rod, lifting device, drop hammer, hammer seat, drill rod, probe. Take the light type dynamic penetration N10 as an example. Let us learn the test methods and key points involved. First, test equipment. Mainly consists of 3 parts: cone head, penetration rod, and drop hammer. The penetration rod is made of a metal pipe with a diameter of 25 millimeters, each with a length of 1 meter to 1.5 meter. Drop hammer weight, 10 kilograms. Second, test key points. First drill to the test soil layer elevation using lightweight drilling tools. Then continuously perform penetration test on the required test soil layer. Second, during testing, drop hammer drop height is 50 centimeters. Allow it to fall freely. Drive the probe vertically into the soil layer. The blow count per 30 cm penetration into soil layer is recorded as N10. When soil layer description is needed, the penetration rod can be extracted. Remove the probe. Replace with a lightweight drill bit. Conduct sampling. This test is generally used for soil layers with a penetration depth of less than 4 meters. In the end, when N10 is greater than 100 or penetration exceeds 50 blows per 0.15 meter, testing may be stopped. 3. Test result compilation. First, sort the penetration test indicators. First, measured penetration hammer blows. Various types of dynamic cone penetration tests use the blow count per penetrating a certain depth, such as N10, N63.5, N120, as penetration test index, through comparison with other laboratory tests and in situ testing indicators. Establish correlation relationships. Obtain physical and mechanical property indicators of foundation soil. To evaluate properties of foundation soil, followed by the corrected penetration rod blow count. Mainly involves correction of the probe rod length. When using heavy and super heavy type dynamic cone penetration tests. When determining the compactness of gravelly soil, blow count should be corrected according to the specified formula. Second, penetration curve. For blow count values obtained from dynamic cone penetration test or dynamic penetration resistance, relationship curves varying with depth should be plotted on profile or columnar diagrams. SHN-POH curve or QH curve, based on the shape of the penetration curve and combined with drilling data. Conduct mechanical stratification of the strata. Fifth, application of dynamic cone penetration test results. First, use penetration curves for mechanical stratification. Second, evaluate foundation compactness. See table 3. Evaluation of foundation bearing capacity. First, use light type dynamic cone penetration blow count N to determine the bearing capacity of foundation soil. Second, using heavy dynamic cone penetration blow count NS, determine the bearing capacity of foundation soil. Fourth, determine the deformation modulus of foundation soil. Fifth, determine single pile bearing capacity. Sixth, determine shear strength, foundation inspection, and identify the foundation bearing layer. Seventh, evaluate foundation uniformity and determine bearing stratum. In this lesson, we learned the introduction of dynamic cone penetration test. Taking the light type as an example, explained the key points of the dynamic cone penetration test method. Hope you can apply what you've learned in future work. With a rigorous and meticulous attitude, approach each test task